So before we get to the concept of a function, we have to start with something called a relation. A relation is simply a set of ordered pairs and we call it ordered pairs if the pairs are numerical. If they're not numerical, we just call it a set of pairs. I'll show you the two cases. Let's take the second case where you have a set of pairs. It's a collection of something. So I have picked 4 different items. I'm going to call those the X's. I have A, which is a letter. We know that. Hashtag is a symbol. 8 is a number. Pi is a Greek letter. So I've put them together because there is an association between the two. In other words, they are related to each other. And if we want to visualize, uh-oh. How did that happen? It's fine. Let's draw one. Oops. So what I'm going to do is I'm going to put all the X items, A, pi, sorry, hashtag, 8 and pi. So we have A, hashtag, 8 and pi. Oops. And the corresponding sort of Y values are letter, symbol, number, Greek letter. And you can say that there is a one-to-one connection. A is connected to letter. Pi is, hashtag is connected or related to a symbol. 8 is related to a number because 8 is a number. We relate pi to a Greek letter because pi is a Greek letter. So we can say that whatever we had in our pair as the first item, A, hashtag, 8 and pi, they are related to the second item in each pair. So I'll call all of these values or to be X and the others to be Y. And I can conclude that X is related to Y and the given set is a relation. Now, let's go back to what we did with the equation y equals x plus 2. we had coordinate paths written out for y equals x plus 2. We had -2, 0, -1, 1, 0, 2, 1, 3, and 2, 4. So we will have the set of ordered paths -2, 0, -1, 1, 0, 2, 1, 3, and 2, 4. Now that is a set of ordered paths because numbers have a natural ordering. We only write it as 1, 2, 3, 4, 5, 6. We don't write it as, 2, 1, 4, 3, 6 on the real number line. So numbers have a natural ordering, which is why we call these an ordered path. You don't have to necessarily draw an ellipse to understand this, or a poorly drawn ellipse in my case. I'm going to write out all the x values. So -2, -1, 0, 1, and 2. The other side, we have 0, 1, 2, 3, and 4. -2 is related to 0. -1 is related to y. 0 is related to 2. 1 is related to 3. And 2 is related to 4. Now, this is a relation. But we know we have x and y, but y in this case is x plus 2. And y equals x plus 2 is an equation, but since we have y and x, it's called a function. So y is related to x, so y is dependent on x. That is, if x changes, so does y. For different values of x, we get different values of y. So y equals x plus 2 is a function. And it is also a relation. But there are cases where a relation may not be a function. So I'm going to start with a relational example and then move on to a function that is not, a relation that is not a function. So So the X values are all fruits, and the Y values are their colors. So I have apple, considering red, of course, there are green apples, grapes, purple, grapes, they can also be green, orange, they are orange, pumpkin, orange. So those are my pairs, and I'm going to put them in the representation that I have. Style, stroke. So as I mentioned, you don't have to necessarily draw an oval. So we have apple, grapes, grapes, orange, and pumpkin. And over here, red, purple, green, orange, orange. So I put 2 grapes, but 1 is enough. And I'm going to connect them. So apple, red, grapes, purple, oops, green, orange, orange, pumpkin is also orange. So I'm going to get rid of that and do it that way. So let me change the colors of these. So if you look at the pictures, or excuse me, if you look at the picture, apple to red is a single line. Grapes, it branches out to 2 different items. Orange goes to orange, pumpkin goes to orange. So this is definitely a relation. But if we had numbers that behave this way, then the equation or the ordered pairs is not a function. Specifically speaking, what would make it not a function is this part. If you have one x value that branches out to 2, I would say put x there. So if one x value is branching out to 2 y values, then it would not make a function, numbers. This is fine, that is fine, that is fine. But the middle two, not okay, because if these are the x values and those are the y values, 1x can go to 1y, and that is a requirement. 1x cannot go to 2y's. 2 different y's can have the same x. So orange, for instance, did I say 1x and 2y's? Yeah. So 2 different x's can have the same y. So orange, pumpkin can have orange as a color. So the one in purple is fine, but the one in grapes is not fine. So if we go back and look at the previous case, everything is going from x to y in a straight line. So that is definitely a function. If you see something like that, it's always a function. The only thing that we cannot see, a set of ordered paths that will not be a function, is the middle two, where you have one value in x that branches out to 2 different values in y. So these are a set of ordered paths, and we want to determine if the set is a relation, is the set a function, both conditions. So we have to put the numbers and look for or watch out for arrows like the one that we did previously. And if we have misbehaving arrows like the one in the middle, then it cannot be a function. So what we're going to do have 2 different images, and I'm going to put in values. So let me put in -1, -2, 2, 1, 4, 3. I already have 4, so I'm just going to leave it as is. And for the y values, I have 4, 9. I have 2 9s, I'll just leave it as is. 3, 11, 1, and 15. So -1 is going to fall, not a problem. -2 is going to 9, and +2 is going to 9, 1 is going to 3. 4 is going to 11. 4 is also going to 15. 4 is also going to 15. And lastly, 3 is going to 1. So 1 to 1, this is okay. 2 different x values can go to the same y value. So we had orange, pumpkin. Both of them went to orange. So the one in purple, if you look at the sketch right here, you can see that resembles the orange pumpkin type of relation to orange. So that's okay. 1 to 3 is also 1 value to 1 value, so that is okay. But 4 goes to 11 and it is also going to 15. So that's like grapes here. Grapes can be purple or green, and that is not okay for a function. So this is not okay. And 3 goes to 1, and 3 goes to 1, and that wouldn't be a problem because it is 1 to 1. So here, what we have is a relation but it is not a function. So we have a relation, but we do not have a function because one value of x can only result in one value of y, or one value of x cannot take two values of y, but 2 different values of x can have the same y value. I call that x and y, and if I write them separately instead of the ordered path or ordered paths, the domain is the set of all x values. The range is the set of all y values. So we have the domain and we have the range. So if I write the set out, I have -1, -2, 2, 1, 4, 3. If I look at the set of y values, I have 4, 9, 3, 11, 1, and 15. Now, even though it is not a function, I just want to demonstrate, what the domain and range are. A set of all x values would form the domain. A set of all y values would form the range. And we typically do this for functions. In some cases where we don't deal with functions, we call it as the domain and the codomain instead of domain and range. Domain and range, more often than not, is something that we use with functions. Okay, so we're going to take the ordered path from the previous problem and put it on this graph. So -1 gives us -4, So the point is right here. Oops. Oh, positive 4, my bad. So -1 is giving us positive 4. -2 gives us 9. Well, I'll just arbitrarily put it somewhere up here. And +2 is also giving us 9. 1 gives us 3. Perhaps I need to move this. I just want to extend it so we'll know what we're doing. So 7, 8, 9, 10, 11, 12, 13, 14. Oops. And 15. So the next one that we had, -2 goes to 9, +2 goes to 9. So 9's way up there. So I'm going to put a point here and 1 there. 1 is going to 3, 4 is going to 11. So I already marked 1 to 3. So 1 to 3 is that point. 4 is going to 11. And 4 is also going to 15. And lastly, we have 3 that is going to 1. So if I had to connect the dots, and if I have to go in order, I'll go from -2 right there. So I'll start right there, go to -1 and come to +1, then go to negative or +2, then come to +3, because they are ordered past. The last two are at 15, so it's gonna go up and will form a vertical line. So here is the concept. If anywhere on the graph you see a vertical line between 2 points, then the graph is not a function. So we have a vertical line there. So we have vertical line, then it is not a function. Another way of looking at this is if I drew a vertical line through the graph at various points, the vertical lines that I draw must touch the curve exactly at one point. For instance, if I drew a line here, it's going to touch the curve exactly at one point. If I drew the line there, it is going to touch the curve exactly at one point. There, same case, there, there, there. In all of those cases, the dotted line touched. Oops, damn it. Weird. Okay, touch the curve exactly at one point. But if I drew a vertical line through a vertical line, you can see that the graph, the vertical line that I drew, is touching multiple points on the curve. So damn it. So the vertical line we drew, it's touching the graph at more than one point. So this is not a function. So you can do this and determine if a given equation is a function or not, or you can graph and do this process of drawing vertical lines. And this is what we call the vertical line test. For functions. So when we draw a vertical line in the domain of the function, the vertical line must touch the curve exactly at one point. So I'm going to show you a couple of examples. So this is a function because I could draw vertical lines no matter where I draw the vertical lines, they touch the curve at exactly one point. So that is a function. Now, if we consider another case, this is not a function because if I drew a vertical line, it is going to touch that curve at more than one point. The key phrase is more than 1 point. If it fails for 2 points, that's it. It doesn't have to touch multiple points. If the vertical line touches more than 1 point, then the curve is not a function. So it is touching more, the vertical line that we drew touches more than 1 point. So what we have is not a function.